So what we're going to talk about next are squares in the different mods, especially the primes. Okay. So what numbers are squares mod 2? What integers mod 2? Like, so what numbers do we have? And we're going to ignore 0. So what numbers do we have mod 2?
Well, we have 0, just 1.
0 and 1. And we're going to ignore the 0. So is 1 a square?
1 is a square.
Alright. What about mod 3? What numbers do we have?
1 and 2. Just ignore the 0.
Okay, yeah. So 1 and 2. Is 1 a square?
Yes, 1 is a square.
Is 2 a square?
2, let's see. I don't think 2 is a square.
Okay. How did you decide it wasn't a square?
Well, so if you only have a couple of choices for squaring numbers. If you square 1, you get 1. If you square 2, you get 1.
Okay.
So there's no way to get 2 with the square.
Okay, very good. So again, it's only 1. Mod 5, I guess, would be next. So we have 1, 2, 3, and 4. All right. What numbers here are squares?
Well, again, 1.
1 is a square. Okay.
Well, 2. Let's say if you square 1, you get 1. 2 squared is 4, so I guess 4 would work. 3 squared would be 9, which would also be 4. And then 4 squared would be 16, which would be 1. So it's only 1 and 4.
Okay.
7.
What numbers are squares here?
So we'd have our 1 again, and we'd also have a 4.
All right. 1, 4.
Oh, so then 3 squared would be 9, which would be 2. So 2 is a square.
All right. So finally 2 is a square. That's good.
Let's see. Now we get 4 squared is 16, so that's 2 again. 5 squared 25, so that's 4 again.
All right.
6, 36, so that's 1 again.
All right.
So we only have 3 again.
All right. Do you notice anything about maybe 2 is weird because it's there's only one number there. But do you notice anything about these?
Well,
Mod 3, mod 5, mod 7.
they're just increasing by 1 every time, I guess.
Okay.
Number of squares.
All right. So how many do you expect to find for mod 11?
Mod 11, 4 or possibly 5 actually.
All right. What makes you say that?
Well, 1, 1, 2, 3. That's beginning the Fibonacci series.
Ah, interesting. 1, 1, 2, 3. So we might get 5. We might get 4. Okay. Well, let's see. Let's see if we can do it.
Well, let's see. So 1 works.
1,
4 works.
4.
3 squared is 9, so 9 would work.
9 works.
4 squared 16, so 5 would work.
All right.
5 squared 25, 3 would work. So 6 squared 36, 3 again. 49, 5 again. 8 squared is 64. That would be 9 again. 9 squared 81. 4 again. 10 squared is 1 again.
Mm-hmm.
And 11 squared would just be 0. And we're ignoring that.
Okay. So how many did we get?
So we do have 5.
We have 5. Okay. All right. So any other guesses now?
Yep. So I think it's going to be the Fibonacci series.
All right. So what do you guess for 13?
13 would be 7. 7 squares. No, 8.
8. Okay.
Yeah, 8.
All right. Let's see. Getting a little tricky to write this, but I think I can do it. Maybe I'll do it in 2 columns. I can do this maybe mod 3, so I can have a little more room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, pretty good for multiple columns. I don't need 13. All right, what are my squares?
So you'd have 1,
1,
2.
2 is a square?
Oh no, 4.
4, all right.
4, 9.
9.
Let's see, 4 squared, 16, so 3.
3.
5, 20, so that'd be 25, so that'd be 12. 12 would be a square.
12 would be a square.
36, so that'd be 10. Yeah,
10.
10 would be a square.
Okay.
7, that's 49. So 10 again. 8
Right.
to 64. That would be 12. 9, 81. So 81. Let's see. So that'd be 3 again.
Yeah. Now you can also, if you want, you could say 9. Is that what you were doing, right?
Yep.
Say 9 is the same as minus 4.
So that'd be 16, so that'd be 3.
Yeah. So,
So,
that helps the calculations a little bit.
so 10 is negative 3, so that'd be 9. 11 is negative 2, so that'd be 4. 12 is negative 1, so that'd be 1.
Okay.
So it just seems to go up and then up the squares and then it just goes back down again.
Yeah. Yeah.
It
Good.
seems.
Nice. So let's see. For 3, we had just 1 square. For 5, we had 2.
2.
For 7, we had
3.
For 11, we had
5.
5. And for 13, we had
2, 4, only 6.
6. Yeah, so it's a tricky pattern. Do you see? But there's still a pattern here. It's just a little harder to
2,
find.
3, 5.
3 goes to 1, 5 goes to 2.
7 goes to 3, 11 goes to 5. So 3 minus 2 is 1. 5 minus 3 is 2. 7 minus 4 is 3. 7 minus 5. 7 minus 6 is 5. So it'd go 2, 3, 4, 6, 2, 3, 4, 6, 7. Let's see. So maybe, oh no. So maybe 1 times 2, that's 2. So that's 1 less than 3.
Okay.
And 2 times 2 is 4, that's 1 less than 5. 3 times 3 is 6, it's 1 less than 7. And then 5 and 6 would also work for 11 and 13.
Aha. So if we do 29, how many do you expect to be squares?
29, so that would be 14
14.
squares.
Yeah, really nice. Then that's right. That's the pattern. Subtract 1, divide by 2. Okay, high five. So I'm going to have you do, away from the work here, I'm going to have you do a multiplication table mod 11.
Alright.
Okay? So you're going to make an 11 by 11 grid
Okay.
and tell me, and then we're going to talk about the multiplication.
Alright, cool.
Alright, so, alright, go ahead and do that.